All right, pay attention, class 9s. Look at the sums over here. This is exercise, I think, 4a. Exercise 4a. Now I have the sums over here. Might be these sums, the order of these sums might not tally with your book because I'm using a different version. All right, but nevertheless the sums are here. I'll give you a copy of my sums. Is that okay? I'm doing all the odd numbers, 1, 3, 5, 7, so on. You're going to try the even numbers, okay? Right, and I'll do the even numbers in the next class. Is that clear, all of you? Okay, so I'm giving you an order of these sums. I'll be giving you a copy of my sums also. You just tally with yours. Right, the first one, it says a hammer exerts a force of so many Newton on each of the nails A and B. Area of cross section, that and that. Nail A 2 mm square, nail B 6 mm square. Calculate the pressure on both the nails. Now this is Newton and this is millimeter square. So 1 millimeter is 1 meter. So if I have to express it in Pascal, that is Newton per meter square, I'll have to convert the millimeter into meter square. So that is how it works. Sum number 1. Okay, force is pressure is force by area. Force is that Newton, and area is 2 millimeter square. Convert that to meter square, so it becomes by 1000 into 1000. Okay, so it becomes 1.5 by 2 into 10 to the power, this goes up. Okay, it becomes 10 to the power 6. Now if you divide this, it comes to 0.75 into 10 to the power 6. Now in physics, generally we express the answer with one decimal place. So if this 10 to the power 6, I make it 10 to the power 5 into 10. 10 to the power 6 is 10 to the power 5 into 10. Now that 10 will multiply with this and you get 7.5 Pascal. Is that okay? The same goes for the next part. Pressure is force by area, force by 6 into that, 10 to the power 6, and when you divide this, it comes to 0.25 into 10 to the power 6. Now 10 to the power 6 will be 10 to the power 5 into 10. That 10 multiplies with this becomes 2.5. Is that clear? Fine. The next one, number 3. A vessel contains water to a height of that. Take the density of water as that, acceleration due to gravity that, and the area of the base of the vessel that. Calculate the pressure and the thrust. Question number 3. Okay, so pressure is, okay, H rho G. Height is given, so many centimeters. Density of water 10 to the power 3 grams per meter cube, and acceleration due to gravity that much. Okay, now when you multiply that, it comes to 14.7 into 10 to the power 3. As I said, we have to give it with one decimal place here. Okay, so I multiply this with 10 and I get that 10 to the power 4. Okay, are you getting me? Right. And then the thrust is force into area. Thrust is force into area. So that's your, thrust is pressure into area. Thrust is pressure into area. So this is your pressure. Area is, okay, 100 centimeter square. I'm converting that to meter. So divided by 100 into 100. 100 cancels. This next 2 zeros here cancels and we get only 10 there. So 14.7 into 10 is 147 Newton. Is that okay? Number 5. Number 5 is calculate the height of water column which will exert on its base the same pressure as 70 centimeter column of mercury. Okay, so density of mercury is that. So here, pressure of water equals pressure of mercury. Okay, H rho G, G and G cancels. Height of water I have to find out. Density of water is 1. Density of mercury that, okay, you multiply that, you'll get so many centimeter. Convert that to meter, divided by 100, it becomes that. Is that okay? Clear that much? Right? Okay. Then comes number 7. Okay, number 7 over there. Okay, look at that, number 7. Number 7 says a simple U tube. Okay, just hold on please.